Alright, so in this talk, I'm going to talk about this work on comparative explanations. I think primarily the work is on recommendations. So my name is Hady. So this paper is appearing in the machine learning special issue. Now, a lot of times I think we have seen cases of recommendations where essentially the platform is going to produce a ranking list of items that they think that you should adopt, right? Things that is something that you might be interested in. Now, increasingly, I think we are seeing that the important thing to recommendation is not just that they will be accurate, but even the way that the recommendation itself is being presented to the user will actually have an effect in terms of whether the user is going to be influenced by the recommendation. So increasingly, we would like to see whether we can provide good explanations to the recommendation so that if the users understand why certain things are given to them, then they might be more likely to accept that. But we also draw the insight that most of the time what the users are trying to do, especially when they go shopping, is that they are trying to make decisions. And the decisions means that they are trying to compare things, and they are trying to understand how is one thing better than another, in what ways, so that they can make that decision. So this is just an example. Let's say we're considering headsets, like those ear sets that you are also using as a microphone. So you might have different aspects that you are concerned about. So things like a battery life or sound quality. That let's say you go to some e-commerce platform, they give you a list of 10. Then you're trying to decide which one should I buy. And it would be useful to know which one has better battery life, which one has better sound quality, and so on. So in that sense, that's kind of what we are trying to do, except that the novelty in this paper is to look at explanation in the comparative sense. Meaning that we will tell you about two things, and between the two products, in what way is one better than another. Now, this is an example of an output that you get from various types of algorithms now. So let's say comparing two products, both of them are Plantronics, but they are different models. Now, one of the baselines is called MTR, which is multitask explanatory recommendation. They will do a point-wise explanation, meaning that they explain one product at a time. So in this case, it will say that its aspect is described by some adjective, right? So then it will tell you, let's say the fit, is it great, the microphone, is it strong, and so on. Now, there was a previous work in terms of doing comparison, but they're just focusing on the direction of comparison, whether it's better or worse, but it doesn't tell you how. So the novelty of this work is to kind of build on top of those things and to be able to say that for given aspects, whether one product is better than the reference item, let's say the recommended item, is it better than the reference item, is it better or worse? And if it is better, in what way? And these are essentially adjectives or opinions that we have to mine from the reviews. Now, this is one example. So just like to give you another example, it could also be like restaurants. You're trying to decide where to go to eat. So then there are different restaurants that you can consider. So in what way is it better? So maybe it's in terms of prices, or it's in terms of some dishes like a salad. So now the whole point of the work then is how do we know what the user is going to be wanting? So how do we produce the top 10 recommendations? How do we identify the aspects that the users cares about? And for those aspects, how do we identify ways to describe them in a way that would actually matter to the user? Meaning it's a personalized way of explaining things to the user. Now, there are a lot of different parts to this, so I'm not going to belabor all of them. It's all described in the paper. But this is an overall architecture, and I think part of this is because of the multi-relational nature of the work, because you have users, you have items, so the way the user interacts with the item depends on the aspect, and the way that the user describes the item also depends on the aspect, because depending on whether you care about battery life or the quality of the microphone, they're going to use different words to describe those aspects as well. So that's why it turns out to be a tensor factorization type of problem, because we have to look at the different ways in which the tensors are related to one another. So for example, the key tensor that we are modeling is essentially user, item, and aspect. So then we are trying to see what is the rating that the user will give to the item for any given aspect. But there will be explanations that come along in terms of how the words are related to each aspect. So they come in terms of additional tensors that we jointly put together, where they're going to share some of the common latent factors. And here, because of the way that users are describing positive and negative opinions tend to be different. So again, I think there are going to be multiple components with respect to that as well. Now, I'm not going to go into the detail into each one of them, but I want to focus on some of the key ideas, because at the end of the day, it's really about the aspect comparison, right? So one idea here is that everything is going to be modeled in terms of contrastive laws of comparative nature. So in this particular case, for example, if we understand that the user I, for a given item j, will have different aspect preferences, we want to preserve the ranking of that aspect. That's why the title of the paper, like learning to rank. Now, there are multiple dimensions to this, because then for a given aspect, for different two items, they also have different comparisons in terms of the quality. Because, especially in a competitive market, usually you don't have two items that dominate one another. Usually the one is better than another one in some ways, right? So we try to preserve those forms of comparison. Now, the key thing then is that how do we mine the opinions that the user is going to use in order to compare products? And those come from reviews. So essentially we extract words from reviews. These tend to be opinion words, both in a positive and a negative sense. And we look at the relations between the aspect K and opinion words W when users are describing different items. So then we look at the frequencies of how they describe items or a given aspect in the positive and the negative sense. Now you get something that is very sparse, but they can then be factorized, and then the factorization results in densification of the overall tensor that we then use for prediction. So eventually it's going to be generating a template. This is the template that we use for explanation generation. So the template, in order to fill the template, there is going to be a component that produces a recommendation. So that's where we get a recommended item, the reference item. And then based on the user's affinity to the various aspects, to identify the aspect that they care most about. And then in the comparison to the reference item, we're going to pick the opinion that is related to the aspects, both in the positive comparison side as well as the negative comparison. Now, there is an interesting question as to which products need to be compared. Like, what do you care about? So if I give you a top 10 list in the recommendation, which ones will you be comparing? So then our intuition is that you'll be comparing two things that have pros and cons. So in that sense, we look at the top 10 list, especially we talk at the top rank, and then we go down the list and find which other items below the top rank will have something that is better in some ways than even the top rank one. So that becomes an alternative that you want to consider. So that is more or less the overall structure of the work. Now, we look at different types of evaluations because it goes in terms of how accurate is the recommendation, how accurate are the words that we use to describe them, and so on. And but at the end of the day, we kind of realize that because if it is going to be explanations, there has to be some form of user-facing evaluation. And so that's what we did. We did a user study as well, in addition to the different types of quantitative metrics that you can see in the paper. And essentially, we are trying to ask the users, do you actually want these kind of explanations that will tell you something about how two things are different in terms of their opinions? And we see that generally they like it, right? So it means that the idea is that they will like the aspects, but at the same time, if you can give them opinions, they will also find that informative. Now, I don't think it's perfect yet, because I think it's still work in progress in the sense that although we're kind of getting the right aspects, the right comparisons and so on, the presentation is still a bit rough because they form a template. Now, everybody says, okay, why don't you use LLM and so on? We tried, right? So when we talk to LLM, giving them prompts and so on to produce this kind of comparative explanations, part of the issue is that the hallucinations that need to be resolved, because LLMs don't know about the products. Some products are very cryptic, LLMs don't know about the users. So in that sense, that is probably a bit of an issue. But something that we did that I thought is interesting is that we use LLM to improve the presentation of the comparison that you're really deriving. Because if you identify which ones are the positive and negative items, what are the aspects of importance, and in what way is one aspect is better than another, that LLM could take those inputs that are the product of the algorithm, and then they can then massage this and polish this into something that looks even better. So in that sense, I think there is still room to further improve the quality of the presentations in that sense, right? So, okay, so I guess I think I'm probably going to the other part soon, but But that's the gist of the work. We are essentially looking at personalized recommendation. The importance is not just the quality of recommendation itself, but we are paying attention to the explanations. And in particular is the way that we are trying to explain recommendations by comparing things, which we think will actually be more informative to the user. Because at the end of the day, that's actually what they want to do. They want to compare and decide what it is that they're going to do. Now, this is made available over this GitHub repo. So if you think that you want to play around with it a little bit, then go ahead and do that. And we reproduce some of the examples that we got as well. So I mean, okay, just go to the GitHub. I think you will find the remaining links there as well. All right. So with that, I think then we open up for questions.
Thank you. Any questions?
Thank you for the very interesting talk. So, may I ask how you choose the reference object in your recommendation to make
the product, the reference product, right?
Yeah.
So we have the recommendation module. We will produce the top K list. So then in the top K list, our assumption is that the user is most interested in the top item. So that is a target item. Then we go down the list and we look at for different aspects. What is the next item that is not dominated by the top item? Not dominated in the sense that it's not worse in every way. It must be better in some way. Then we look at the pros and cons, and that becomes the comparison. Now, that's just a way to pick the examples, but you can use the comparative explanation for any pair of items.
Yeah, thank you.
Any more questions?
Thanks for your excellent talk. I think I have one question about your last explanation about introduction about using the LLM, large language model, to generate the synthetic data. But I'm wondering that if that's possible, we use it to improve our current model. But is there any side effect? Something like maybe our model affected by the pre-trained large language model, and it is make our model far away from the target customer.
Yes. Okay, so yeah, that's a good point. All right, so as of now, what we use LLM for is not integrated into the model in a way that is affecting the outcome of the model. The model is completely a learning model. You will output the explanations based on different aspects, opinions, and so on. We only use LLM at the very final stage to polish the presentation of the explanation. So meaning that as opposed to getting something that might, the green thing is actually what we produce at the beginning. It may look a bit rough because they're not always grammatically perfect and so on. So we only use LLM to rewrite those. Where we are not asking LLM to produce a recommendation or to produce an explanation.
Okay, thanks.
I have one last short question. You said that you use the user's preference in terms of the aspects that they're more interested in. Is that for the total ranking as well, or only for the explanation?
It's also for the total ranking.
Oh,
so the way we extract the data is mostly coming from reviews. So based on the reviews that the user has written, because they mention aspect words and so on, so then we take that into account. And the eventual recommendation is a combination of the ratings as well as the different aspects. So that's part of the recommendation.
Okay, thank you.
Thank you.
Okay, thank you so much.
All right, thank
If
you.
you have any more questions, just catch up.
Yeah, just catch up.
Yeah.
Sorry.